this is maybe something that's very important to understand. I think we've only trained about 1% of the AI that we're eventually going to train, right? We've done chatbots. Chatbots ultimately are a very, very small portion of what the AI economy will be. We are in the first kind of out of the first inning with AI. And I think that the demands, just the demands for AI training are going to go up a ton. So where is it going to go? You remember I mentioned Deepu Talla, and he was the guy who said we want to be 10 years ahead. So now all the guys, Ilya Sutskever, all the Alex Krzyzewskis, Andres Karpathy's, the guys who built all these chatbots, they've moved to doing this. This is where all the VC money is going. This is where all the tech talent is going. Robots. And what they call physical AI. Okay? Now they kind of have to invent this from scratch. With chatbots, they had the advantage they could train it on the whole internet, right? But there is no internet of like physical data, like how to move stuff around. So what they're doing is they're putting industrial workers basically in like motion capture data suits, and then having them go about their day doing whatever the tool they do. And then the information from each little joint on the data suit is uploaded into the cloud, where the robot can use it as, the AI can use it as like raw training material, okay? Another thing they do is they do teleoperations. So they put a VR headset on you, and you just kind of steer the robot around, and it moves around. And slowly it's learning from how you move, how to move on its own, okay? So these are the data suits. Now, Nvidia doesn't sell these, okay? But what he does sell is kind of the platform that uses that data. So when you train a robot in the physical space, basically what you're going to do is you're going to put it through 100,000 kind of basically fake simulated environments that you create to kind of train its brain to move its joints. And you'll vary things a little bit. You'll vary like gravity. Or you'll be like, what if the robot's joint was a little creaky right here? How would it respond versus this next model? Now, the interesting thing about robots is that they have a hive mind. When one robot learns to do something, every robot learns it. It's uploaded to the cloud, okay? It's run through this digital sim, and then it's downloaded back into the chip, okay? What is that chip? The robot's brain, it's not in its head. It's right here in its chest. They put the robot's brain in its torso, okay? And this is a very specialized chip that you need. When you're on your ChatGPT or on an LLM and you try and interact with it, it basically ferries your request to some giant data center off in the country somewhere, processes it, and sends it back to you. The robot cannot afford to do this. There's too much lag. It's got to act in real time. This is called edge computing, right? It happens right in the robot. Can't communicate with the data center. There's not enough time, okay? Jensen has been building edge chips for robots since 2017.